Hello everyone, welcome to another video from learndataSkill.com. I'm Marcus. So in the previous tutorials, I show you how you can do machine learning with using linear regression. We actually use linear regression to predict the sales of the company by doing advertising in different social media platforms. And also I show you how to do logistic regression for another example. And also I have shown you how to do logistic regression with using Orange, which you do not need to do any programming at all. And in the last tutorial, I show you how you can do machine learning with using support vector machines, which is one of the most powerful machine learning technique that you can use for the purpose of regression. So in this tutorial, I want to introduce to you another machine learning techniques, which is called K-nearest neighbor. So what is K-nearest neighbor? I'm going to introduce to you later, and I have already prepared some presentation slides and also an example that we can go through together so that you will get yourself familiar with what is K-nearest neighbor, and maybe after today you will be able to use it in your work or any other problems that you are facing in the real life. So without further ado, let's look at the presentation slide today. So I'm going to go through with you what is K-nearest neighbor, and then I'm going to explain to you how does K-nearest neighbor works, how do we choose the factor K, which is one of the most important performance affecting factor in this algorithm, and also when to use K-nearest neighbor. So you can see that K-nearest neighbor is actually a supervised machine learning method that you can use for regression and classification, and most of the time people are using it for classification. So it actually classifies a data point based on how its neighbors are being classified. So if you look at the example here that I have in my presentation slide, if you have a data set which says that for certain length of ears and certain sharpness of jaw is a cat or a dog, you can actually give it to K-nearest neighbor algorithm, and then it's going to take this data set as a reference and also learn from it, and then whenever you give a new input to the algorithm, and it's going to base on the attributes, and then it is going to search for the neighbors of this new unknown data point, and then it's going to give you an output of whether this is a cat or dog. So the important terms here is the neighbors, and the number of neighbors is also important, which is the K that we're talking about here. And in the next slide, you can see that I'm going to explain to you how K-nearest neighbor works. So K-nearest neighbors actually learns from the label data sets, and then it classifies new data points or unknown data points based on the similarity, or so-called the nearest neighbor, as I have just mentioned just now. And to identify the nearest neighbor, K-nearest neighbor actually calculates so-called the Euclidean distance. So the formula of Euclidean distance is mentioned here. So basically the distance between point P and Q is Q1 minus P1 square plus Q2 minus P2 square, and then the square root of the total. So this P and Q are actually attributes in the data set. So if you have only two attributes, then you will have the 1D distance. And then if you have more data attributes, then you will have Euclidean distance in a higher dimensional space. So if you look at this graph, you can see that this scatter plot, we plot the flower petal length and flower petal width, and then we have three types of flower in this plot. So three types of flower are having different petal length and petal width, and it is easy to separate them into three clusters by using these two attributes. So if let's say you have a new data point that you want to check whether it is belongs to which type of flower, for example Setosa, or versicolor, or Virginica, you can actually put the data point here, and then you specify the number of neighbors that you want to check against. which for example in this case we say k is equal to 5, and then we're going to look for 5 nearest neighbor nearest to your data point, and then we are going to see out of these 5 data points which types of flower are them. And for example, if 3 out of 5 neighbors belongs to versicolor and 2 out of 5 belongs to Virginica, we're going to say this new data point actually belongs to versicolor. So you can see that actually specifying k is very important to this algorithm, because if you specify other number of k, for example k equals 7, then you will probably have more Virginica than versicolor, and then this new data point is going to belongs to Virginica instead of versicolor. So we're going to go through later on what is the correct procedure of determining what is correct k to be used. And yeah, so look at the next slide. You can see that how to choose factor k. And choosing the right k in k-nearest neighbor algorithm is not known as parameter tuning, and normally we will go for odd number of k, because if you choose for even number of k, and then let's say you have 2 neighbors that is belongs to dog, and then 2 neighbors is belongs to cat, the algorithm is going to confuse of whether this new data point should belongs to a cat or dog. So make sure that you select odd number of k. And then normally when we want to use k-nearest neighbor to perform prediction for or train a data, or we want to use k-nearest neighbor to train on a data set, the first k that we normally use is the square root of n, which the n is the total number of data points in your data set. And this is not a golden guideline, but it is a norm to start with that. And we're going to look at it later of what k we're going to use for our problem. And so when to use k-nearest neighbor, given that we have so many algorithms, and what are the pros and cons of k-nearest neighbor? So k-nearest neighbor is a supervised machine learning technique that you need to feed it with a label dataset. So if your dataset doesn't label with the response variable, then probably you don't want to use k-nearest neighbor. Instead, you want to use other unsupervised learning techniques such as clustering. And k-nearest neighbor is suitable for small data sets because to calculate to look for the nearest neighbor, we actually want to calculate a Euclidean distance. To calculate the Euclidean distance for small data sets is normally fast and less computational expensive. But if you have a very big data set, then the algorithm might take quite a long time to give you an answer. So you may want to consider k-nearest neighbor if you have a small data set with a little number of variables. So, and also k-nearest neighbor is a lazy learner because it actually don't so-called learn from the data set. Instead, it use the training data itself for the purpose of classification of the new unknown data that you feed into the algorithm. So next we are going to look at how we can write some code, and then yeah. So today the data set that we want to use is called hard dataset, and to download the dataset you need to go to Kaggle, and then I'm going to put the link in the description of this video later. And just go to Kaggle and then look for this dataset, HealthK dataset on heart attack possibility. And we have a lot of attributes in this dataset in which we are going to make use of these attributes to determine whether a person has less chance of getting the heart attack or more chance of getting the heart attack. So our response variable will be the target, which is the variable that we want to predict or classify. We're going to take in these other variables, and then from there we are going to ask k-nearest neighbor to classify whether a person has 0 or 1, which is a less chance of getting a heart attack or more chance of getting a heart attack. So go ahead and download this data set and save it in your folder, and then after that we are going to go to Google Colab, and we're going to create a new notebook, and we're going to upload the file to the Google Colab, and then from there we're going to explore the data, and then do some visualizations, and after that we are going to train the dataset with the k-nearest neighbor algorithm, and finally we want to do some prediction for the test data as usual. So without further ado, let's get started. So the first thing that we want to do is to load in the dataset that we have downloaded. So I'm going to say step 1, load the data from google.colab import files, and then upload that is equal to files.upload. Go ahead and run this, and then you can go ahead and choose the folder which you store your data, and then open. So once it has been uploaded, you can see that it will appear in the file folder here. I have downloaded 2 times, so I will delete the one that is redundant. Cool. So the next thing that you want to do is to probably I want to copy all the attributes to our notebook so that we can refer them quickly. And so let me check. I have already copied it. Yeah, so I'm going to keep it here, and then so that we can quickly refer to it later. And so the next thing that we want to do is to read the data into a pandas data frame. So as usual, I'm going to import all the libraries that I want to use, including pandas, numpy, matplotlib, and also seaborn. I'm going to just copy paste to save time and go ahead and run it. You can see that I load in numpy, pandas, seaborn, and matplotlib, and then I also initialize the seaborn. So if you don't know what is seaborn, it is a plotting engine that can make your matplotlib plot even more beautiful. So yeah, the next thing that we want to do is to load in the data into a data frame, and I'm going to say ef is equal to pd.read_csv, and then our data set is called heart.csv. Cool. So after that we can step 2 is to explore the data. So we are going to say df.head. So from here you can see that we have our response variable, which is the last column, target, and then we have so many different attributes which we can use to train our algorithm. And let's take a look on all these attributes and then see what they are referring to. So the first one is actually the age, the second one is the sex, either male or female, and then the second one is CP, chest pain type, third one is chest BPS, fifth one is cholesterol serum, fifth one FBS is fasting blood sugar. Then we have resting electrocardiographic results, and then we also have maximum heart rate achieved, exercise induced angina, OPIC. So many deep and complicated terms. I'm not a bio guy, so I don't know all of this, but it's okay. We can just use them for the purpose of training our data and training our machine, and then let it to make decisions. And then we also have slope, CA, tau. If you want to understand more about these terms, you can Google it yourself, but I'm not going to go deep into detail here. My goal is to show you how you can use k-nearest neighbor and then find out whether a person have a higher possibility or less possibility of getting a high attack based on this data. So the next thing that we want to do is probably df.describe. Come on. And then from here you can get some statistical value of these attributes, and also we can say df.info. So here we want to see that we have 303 entries, which is number of rows, and then we also have this data set in integer and float data type. We don't have any object data type, and therefore we don't have to do any dummy variables, so we skip one step. And the next thing that I want to do is to probably do some visualizations. Here I want to do a heat map to look at the relationship between different variables. This is also important for a data scientist in case you want to investigate what is the relationship in between different variables, whether they are correlations. For example, whether the heartbeat rate of human or male is faster than female, or whether that will affect the heart attack possibility or not. So I'm going to use Seaborn, and then step 4 is exploratory data analysis. And I'm going to say SNS dot set, and then RC equal to figure dot fixed size and 10, and then SNS dot set underscore context talk, and then font scale is equal to 0.5, and go ahead and run that. And then we're going to say SNS dot heat map our data frame, then the correlation, and then CMap is equal to rates, and then annotation is equal to true. Yep, cool. So we plotted our heat maps, and then if you get a negative correlation value, it means that there is a negative correlation, which means the two values are moving in different directions. And if you have a positive correlation, and that means the two values are correlated in the positive direction or correlated in the negative direction. So and the magnitude of the value is how strong they are correlated. So we can see that for the target is actually quite strongly correlated to CB and Talak, and also the slope positively correlated, and then is quite negatively correlated to exang, O peak, CA, and tau. We probably want to copy these variables here again for you to do some reference of what these variables are. For example, CP is a chest pain type, and then TALA is the maximum heart rate achieved. So you could probably say that the higher the maximum heart rate achieved, the higher the possibility of getting a heart attack, which is logic. Cool. So yeah, for the rest of it, I think you can explore it yourself, and I think I want to stop here for this part 1 of the video, and then in the next video I'm going to finish up everything by training the data, and I'm also going to split the data into train dataset and test dataset, and then finally we're going to do some prediction with the test dataset. And if you like my video, feel free to click the like button and follow my channel by clicking the subscribe button, and I will see you in the next video.